Antiderivative versus integral. So when we were doing our derivatives, specifically when we were kind of looking at physics, just to give a concrete example, if I was given a displacement function, I took the derivative of that to get a velocity function, and I took the derivative of that to get my acceleration function. If I wanted to work backwards, if I gave you the acceleration function and needed to know what was the velocity function, this is when you would take an antiderivative, because an antiderivative, in layman's terms, undoes a derivative. It tells you what was the original function before I took the derivative. So this allows us to work backwards through the problems. I could give you acceleration and you could go backwards and tell me displacement. So antiderivatives give us a function. Definite integrals, again, if we look through the eyes of that physics example, I want to know the particle's displacement between 4 to 6 seconds in this velocity time graph. So I want to find the area under this curve. That's when we would do a definite integral, because a definite integral is going to pop out a number. It's going to give us a value, specifically the value of the area underneath that curve. So instead of having to find the function and plug in the numbers, this is going to do all of it for us. So big difference, antiderivative function, definite integral, number. All right. So let's work through this problem here. So we're going to apply this rule here. When we're looking at just a constant here, remember this has an invisible x to the 0 beside it, because x to the 0 is just 1. Anything to the power of 0 is just 1. And if we think of our derivative rule, remember, if I was to take the derivative of, say, 4 to the x, well, this would be 4 to the 1 x minus 1, which would give me 4, technically x to the 0, so 4. When we take the derivative of a coefficient with just a single variable, that variable disappears. So when we take the integral of it, that variable comes back. So this is going to be 4x to the 0 plus 1 over 0 plus 1 minus x to the 2 plus 1 over 2 plus 1. Again, just applying this rule here. Evaluated from 0 to 4. So we're going to simplify. This is going to be 4x minus x to the 3 over 3. And because we've been doing derivatives way more than antiderivatives, I like to stop and check to see if I got it right. So I like to take the derivative of this. Well, the derivative of 4x is going to give me 4. The derivative of x to the 3 over 3, well, that's going to give me 3x squared over 3. Those are going to cancel out. And yeah, that gives me what I want. So I just like to do that check because we're usually way more comfortable with derivatives than antiderivatives. All right, so now we need to evaluate this, and we're going to go the second value minus the first value. So we're going to go f at 4 minus f at 0. So we're going to do 4 times by 4 minus 4 cubed over 3. Subtract. Well, this is really nice because 4 times 0 is 0. 0 divided by anything is 0. So we just have to focus on this side first. First part is easy. 4 times 4, that just gives me 16. 4 cubed, that's going to give me 64 over 3. Well, I can't subtract fractions without getting a common denominator. So that's going to give us 48 over 3 minus 64 over 3. It's just going to give us negative 16 over 3. So this means that our area, because it's negative, is underneath our curve.